Hi everyone, Mr. Hersey here for Activity 4, Electric Circuit Interactions. At this time you have written down the two key questions of this, which are what are the defining characteristics of an electric circuit interaction, and then what are some variables, what are some things that influence an electric circuit interaction. All right, a cell. What is a cell? So a cell, this right here is a cell. It's a D battery inside of a cell holder. That is the definition of what we are going to call a cell for our electric circuit. The first thing it asks you to do is to draw an electric circuit. If you look on page, 58, I believe, it has pretty much at the top all the things that you would need. So I like to use two batteries. That should make sense later on in this. But we have two batteries. A key to this is you have to make sure it goes positive, negative, positive, negative. If I flip this one around and I had a negative going to a negative, the electric current would essentially be butting heads with each other, and things wouldn't occur. And you have a switch here. Okay, when you connect all of these together in a circuit, okay, and you put the switch down, lo and behold, the light lights up. Okay, so this is what you would need to draw for expiration 1. All right, and as you're doing that, we can talk about how many connections to each element. So if I see here, there's 2 connections to the switch, there are 2 connections to the light bulb, there are 2 connections to each of the cells. So the answer is 2. There are 2 connections. You have to have 2 connections to each item. Okay, and then when does it occur? Okay, obviously it does not occur right now. Okay, it only occurs if I take one single piece off of this. It will not occur. It only occurs when all metal parts are in contact with each other. All right, so for expiration 2, I need to get an iron nail, paper clip, pencil, metal end of a pencil, and clothing. Okay, so my paper clip here. Sorry, we can go with nail here. Okay, paper I can get right here. All right, so let's take the switch out, because a switch, it just makes it so that you're not leaving it on. You don't really need a switch to make the circuit work. Okay, first one, iron nail. So if I connect this with 2 different parts, does it light, is what it's asking. The answer is heck yes it does. All right, paper. Absolutely not. Paper clip. Yep. Pencil. Nope. But metal end of a pencil. Yep. All right, article of clothing. This all depends on what you would want to do. If I did this lanyard on the metal end, okay, absolutely. But if I did the actual cloth part of it, okay, no. And you probably have done this before, but really you need metal objects to contact each other for the light bulb to go on. It's not going to work if you don't have those metal pieces. All right, so next, exploration 3. Oh, we're just flying through this right now. A series versus a parallel circuit. Now, a series circuit, okay, is one, your book calls it a single loop circuit. All right, so you can have multiple light bulbs in the circuit. This one's does not want to go. Okay, you can have multiple light bulbs in the circuit, all right, and you can see they're going on, but you know, again, the more resistance you have, the more materials you have in your circuit, the less, you know, current that is going to be going through, and that's why they're not lighting up a lot. But this is a series circuit because it's one loop, okay? It does say if you take out one of the light bulbs, the other one goes off completely, all right? And again, if you take out any one of these connections, the whole thing goes out, okay? I always relate to these to the old school Christmas lights that you could unscrew one and the whole thing would go out, all right? And then you have what is called a parallel circuit. I'll just use this one. Okay, a parallel circuit is known as a multi-loop circuit. That's what your book calls it, multi-loop. So it's more than one loop that makes these go on. And you notice that light bulb is going on just barely, and this light bulb is now going on just barely, okay? But again, each one of them has their own connection back to the cell, back to the source of the energy, all right? So if I unscrew one of these, the other one stays on, okay? One thing that you might not be able to see too, because I just switched to one light bulb, the energy in this, they're getting the full amount of this one battery's current, okay? In a series circuit, they would share, they would only have half this current, so it would be really hard to even see that they were working at that point with one battery, okay? So parallel allows you to you know, keep light bulbs on even if one goes out. It also gives them brighter energy, but it's going to use more energy, more power to make that happen. All right. And then expiration 2. Okay, so we only need one cell. Okay, so if we have one battery, this is what it looks like. Okay, if we add on another battery, you got to make sure that they go positive, negative, so I don't mess it up. 2 batteries, much brighter. All right, it asks you about 3 batteries, so I need to get one more battery and one more cell holder. And I'm sure you can imagine what's going to happen with 3. In years past, kids love to like see how many it happens, and they think for whatever reason the light bulb's going to blow up. It just shorts out. And these aren't cheap light bulbs, so that frustrates me. Okay, so here would be 3 batteries. Okay, notice how it's even brighter now. Okay, so 3 batteries is even brighter. So then you can go down and answer. As the number of cells increases, what will happen to the brightness of it? All right, so expiration 5, there's going to be, I don't have an ammeter. I've tried this, actually, Mr. Pendergrass has ammeters, and we've tried this a couple times, and it doesn't work out super well with the ammeters for whatever reason. I just don't think they're, pricey enough to do what we're looking for it to do, but I have a picture of a simulator with ammeter readings on it, and I want you to take that for expiration 5. You can find the definition of ammeter in your book, but the number of cells and the electric current, go to the picture that's on Google Classroom and get the numbers from there, and then you can make your graph. Okay, again, this should be a lot easier this year, as that we've taken you, or I've taken you through what you need in order to get this done. All right, have a good one. See you in class.